Hi folks, let's talk CNC Coolant Basics. So I love learning, but what I'm excited about is QualiChem offered to come in and help us produce this video to talk about the basics of a CNC coolant, including how do you pick one, does it matter, how do you get started, all that good sort of stuff, which is awesome because we've got someone here who's actually pretty knowledgeable about the subject. So with me is John Wiley from QualiChem.
Great to be here. First exciting opportunity to see your shop.
Thank you. We had some great feedback from our video when we were talking about water quality, which I want to come back to that in this video, but why don't we take a step back and start with, I'll be cynical. Does coolant matter? Why does it matter? What should they think about when they're starting off?
Well, I guess the first important answer to that is coolant absolutely matters.
Okay.
Coolant really should be viewed as a tool, and not as a lot of shops unfortunately do. They view it as a necessary evil.
Right.
I need something to wash away the chips. I need something to prevent oxidation. The reality is a good, well-maintained, well-applied coolant is really going to be a benefit in the production process, without a doubt.
So we've always heard it does three things. It evacuates your chips, it provides a lubricity to reduce cutting forces, and then there's the thermal element, whether it's cooling the cutting tool or cooling the workpiece. What's your 2 cents on that?
Well, so when shops ran mostly straight cutting oils, the primary function was lubrication.
Okay.
With the water diluted products, cooling is your number one effect. Then lubrication. And that comes down to, there's chemical lubrication.
Okay.
Is there something in the product that can react with the metals to facilitate cutting? Or is there what we call boundary lubrication?
Okay.
Just the physical thickness of the components in the coolant, providing a boundary between the tool and the workpiece. And then you get into chip evacuation, or swarf if you're grinding.
Yep.
The one thing a lot of people don't consider is oxidation or corrosion.
Okay.
A lot of metals, if you just cut them and leave them exposed to air, they will tarnish or they'll discolor.
Sure.
So a lot of cases you try to prevent that corrosion with the metalworking lubricant. More of an issue for shops running cast iron.
Okay.
If you were to just cut cast iron dry, at some point you're going to need to protect it from rusting.
Got it.
So there's really four. It's cooling, lubrication, chip control, and oxidation control.
Interesting. Does that matter with aluminum? I believe the second you expose a new layer, it oxidizes.
You start oxidizing, yes.
Okay.
Now there are components you can put into a coolant that'll prevent that layer from oxidizing.
Why do I care if it oxidizes in the cut? Because it's going to oxidize milliseconds later anyways?
Well, it's not, no, actually, if you're using a coolant that's designed for aluminum, you're actually passivating the surface.
Okay.
So you're preventing the oxidation process from taking place. So, a shop like yours where the aesthetics of what you're making are important.
Yeah, sure.
The surface finishes that you're getting from a lot of the cutters you're running, they wouldn't look as nice if you weren't using a coolant that helped the surface remain shiny. Now, in a large production facility where surface finish of the part's not necessarily important, it becomes less critical.
Got it.
And that really, that's part of the discussion in how do I select the product is what kind of work are you doing? What do you need to be demonstrating?
Yeah, right.
If you look at a lot of the shops on Instagram that post up pictures of the work they do.
It's a very important metric is your Instagram profile for your machine shop.
I mean, how shiny can you show your part?
Right.
A lot of these guys are really proud of new cutter, right speeds and feeds, good coolant, it's a mirror.
Right.
The reality is in a lot of very large production shops, that kind of stuff is less important.
Right, or even bad, long story, but about the surface finish of your parts, you don't always want perfect mirrors. But I always thought it had more to do with the fines, like keeping your coolant clean, which is a whole other subject, or the lubricity, but interesting on the sort of passivation side.
Yeah, there's a lot that goes into it. But yeah, fine control is one, tends to be more of a grinding issue than on cutting.
Okay.
But recutting chips, or if you get to the point where your coolant's so loaded up with fines, you're actually machining with a slurry,
right,
you're not helping yourself.
Right.
So
to bring it back, I'm buying my first machine. I'm going to do what a lot of job shops I think do, which is you might focus in aluminum, but you're not going to turn down that 4140 job. You're not going to turn down titanium. What are some educational points, and maybe this is a good time to introduce the idea of oils versus synthetics versus semi-synthetics?
Sure. The first and most important thing is understanding what your material mix is today.
Okay.
Where you might see it going tomorrow. Ultimately, selecting a fluid that's designed to run a variety of metals is going to be the most important first step.
Yep.
Are there components in there to help corrosion with iron-based metals. You know, you're running 4140, that might rust.
Okay.
Are you running aluminum, which is prone to corrosion, different sorts of corrosion, obviously? Then you run into, are you going to be doing any brass or copper, or anything that contains copper, because those are affected by other chemistries as well. It's generally speaking easy to find a coolant that would be, let's say, what we call multi-metal, multi-purpose. Within that multi-purpose, multi-metal formulations, that's when you can start looking at, well, do I need something with a lot of oil in it? Do I need something with a little bit of oil in it? Do I want something with no oil in it because I want to be able to see through the fluid? I want something that's clear.
So that would be like the synthetics, which I know is a little bit of a loaded term.
Yeah, synthetics, in my opinion, as a marketing guy, is probably one of the most overused and misunderstood words in our industry. Generally speaking, when it comes to metalworking fluids, if someone is talking, it's a synthetic, the term has always sort of been understood to mean free of mineral oils.
Free of oil. So don't laugh. An oil or mineral oil literally is something that we extract from the earth. It comes as a natural resource.
Yeah. So the oil companies extract crude oil from the ground, and then they refine it into a million different things. Base oils are one of the components that come out of the crude oil, and base oils you can buy for different purposes, for formulating motor oils, for formulating a hydraulic oil or a whey lube in your machine, or you can buy specific base oils to be used in metalworking fluids.
Okay.
They're mineral oil, they're naturally crude derived. Outside of that, you get into, there are vegetable oils now that are very popular for use in metalworking fluids. There are synthetic vegetable oils. There's another family of chemistry.
Don't say that, that confuses me.
Yeah,
so like, I know John Grimsmo bought a Swiss lathe, and he's running I believe, a true oil in it. So it doesn't mix, so you don't put any water in it.
Correct.
Okay.
Yeah.
That's pretty common, I think, in that Swiss world.
Running a straight oil is more common in the Swiss world because of the way the machine operates. A lot of the components are lubricated by the cutting oil itself. Although less so today than in the past, especially when machines used to be driven by cams.
Right.
Today, a lot of those components that need lubrication are internal and don't really see the cutting oil.
Got it.
But cutting oils, generally, from a cutting perspective, offer a lot of benefits. The downside is cutting oil smoke if there's too much heat. And that's why coolants started to become more popular in the 60s and 70s as machine speeds and feeds and tools were capable of more. Well, so is heat now. There was more heat in the applications. So people figured out how to mix oil and water, keep it together, provide some cooling, provide some lubrication. Well, the next thing that they had to contend with was oil and water mixed together will have a tendency of going rancid and starting to smell very badly.
Yes.
So then having to control the biology that can take place in a machine was sort of the next phase in development. But yeah, whether it's a synthetic product that doesn't contain any oil, or a semi-synthetic, which is a blend of chemicals and oil technology, or the older style soluble oils, regardless of which family you're selecting from, it's possible to find something that's multi-metal.
In each of those buckets.
In each of those buckets.
But for the sake of being blunt, would you say that most new job shops that want a multi-purpose coolant these days are probably going to be best off with some type of a semi-synthetic?
Yes, because semi-synthetics can be more abuse tolerant than a synthetic or a full soluble oil can. Because if you don't maintain a synthetic correctly, if you don't use the right water quality, there's a lot of things that can go bad with a full synthetic that you have more time before that bad shows up in a semi-synthetic. Because all the issues that are possible with a synthetic are still possible with all the other technologies.
In terms of
and
the
vice
benefits.
versa. Benefits or downsides.
So that's the thing I've really enjoyed, and I want to share with you guys learning this is we kind of got bit because we just went into this not really appreciating the differences between a semi-synthetic and a synthetic, and really the differences are incredibly different. It's one of the reasons that prompted us to do that water video was just how absolutely important water is in this stack of things. We focus so much on the machine tool and the fixtures and the cutting tool and speeds and feeds, but the reality is coolant really is an important thing, and it's not just the science of it, it's the fact that you got to live with it. You've got to have it not only focused on the day that you mix it, but you've got to have it work for you every day you turn that machine on. And there's that kind of, what do you call it, the
human aspect.
Yeah, you call it the human aspect of it, which I love because not all of us are, a lot of us don't really care about coolant on the days. We just want it to do something really well. So that human element of SemiSynthetic seems to be a pretty good offering these days.
Yeah, it's a good balance. If you're working in the fluid yourself, or if you're an owner-operator, startup shop, you're going to want to like the way it feels on your skin, the way it smells, the way it keeps your machine. You just invested X number of thousands of dollars in the piece of equipment. You don't want it getting rusty or dirty right out of the gate. So those are, that's more the human side of it. Mm-hmm. How does it cut? Where's my return on investment from that perspective is very different. Yeah. Every shop's different when it comes to balancing the human and the engineering side of things.
Can you share a layman's explanation on what the touch and feel of the part into your hands and the smells would be across the oils, semi-synthetics, and synthetics?
Might be a little bit difficult to generalize, but if you start with the soluble oils, which are the older technology, mostly oil and oil-soluble additives, diluted with water, generally those are going to feel more oily.
Okay.
And then as you swing through the semi-synthetics, which might have as much oil, but other components as well, again, depending on what the product was designed for, it's also going to have an oily feel to it. If it's something that's designed for just cast iron, the oil content will be much lower, so there won't be quite as much of that slipperiness.
Yep.
And then once you get into the full synthetics, again, depending on what they're designed for, they might just feel like water between your fingers, or depending on if they have heat-activated components, the heat of your fingers might make it enough that it feels slippery.
So that's what I remember noticing when I've touched parts cut on a synthetic machine or machine with synthetic coolant, is they feel slippery in a kind of a strange way.
Yeah.
That's common?
Yeah, well there's no oil in them. Again, that goes to the synthetic definition. But there are what we call polymers. But the polymers in a full synthetic coolant are not slippery typically at room temperature. But once you start applying heat to them, they're inversely soluble, so they come out of solubility.
Really? Oh, that's pretty cool, actually.
And are available to do what they're intended to do. In this case, provide lubricity. And that's why one of the biggest challenges in the past for shops that do a lot of prototype work on aluminum, doing a lot of small holes, a lot of tapping.
Yeah.
In the past, it was challenging for full synthetic to be effective there because you're not generating as much heat tapping aluminum as you would be tapping 4140.
Sure.
So you're not activating the raw materials in the full synthetic to take advantage of what's there. And that's why, almost every reputable coolant supplier will have a range of fluids.
Yeah.
It's rarely one size fits all for everybody.
Right.
And have that be optimized, with the exception of products that kind of fall in the middle of the semi-synthetic range.
So what we've been told, we use a lot of 251C, and we've been told that's kind of fits the bill of, look, we're a general purpose shop. We'll do the same machine. We'll be doing the materials we've already been mentioning on this talk. So are we paying the price? Are we sacrificing something by not using something that should, like when we're making our aluminum fixture plate, should we be dedicating a certain coolant type to that machine?
Well, what happens when it comes to dedicating a fluid for either a machine or material is the supplier's not putting a lot of stuff in there that you're paying for that you don't need.
Okay.
So if I sell you a product that's designed for titanium and you're running it on aluminum, it's going to work great, but you're going to be paying more than you need to.
Okay.
Because there's components in there you're not taking advantage of.
Got it.
The 251C is one of our premium semi-synthetics. It's got a little bit of everything in it. So whether you're cutting steel, whether you're cutting aluminum, whether you're cutting yellow metals, whether you dabble a little bit occasionally in some of the alloy steels and for aerospace, or PH series stainless, or titanium, or you get into Inconel a little bit, is it going to be optimized for any one of those metals? No.
Okay.
It's sort of optimized for a shop like yours, where today you're doing aluminum, tomorrow it might be steel. You don't know what project's coming in the future. Right. So it's a multi-metal, multi-purpose fluid. We've got guys that run that for grinding, not just chip making, lathe work, mill work, a little bit of everything.
And if I'm going to use, nowadays it seems like there's more options ever. There's MQL, there's flood coolant, there's through spindle coolant, there's high pressure through spindle coolant. Any advice on what you should think about?
I think if your machine came with a sump and is capable of flood coolant, that's what I would suggest using. Anytime you're trying to minimize the application of something, to be able to repeat it the same way over and over again becomes challenging. In a prototype environment, it's easier to use the mist applicators, the fog busters. I think a lot of people will use because you're not evacuating massive amounts of chips, because you can't forget that's part of the role the fluid provides as well. It just so happens that 251 works well in the fog busters, but really that wasn't sort of the intended design or focus of that product. We have products that we've made that are designed for minimum quantity lubrication systems. Those tend to be straight oils more so than coolants.
Interesting.
The main reason why on the mist applicators, if you're not good about maintenance and keeping the nozzles clean, that last droplet that's sitting on the end overnight, the water evaporates out of it, and you get a little bit of concentrate or residue forming on the end of the nozzle. You don't really get that with an oil. Right. So if you're good with maintenance, it's easily overcome.
Well, but that's part of the big thing is when you're thinking about it, it's easy to talk a big game on maintenance. But the reality is, I think shop maintenance is actually pretty difficult, whether you're a one-man shop or even as you grow. So I think that human element of a coolant that's more tolerant of everything we've been talking about, the water quality, maybe a little variation in the bricks, the overnight dripping. Again, semi-synthetic wins there?
Yeah, I think in most cases it does, because you've got oil for corrosion protection. You've got a variety of oil-soluble additives that are also suitable for preventing corrosion on different metals, not just irons. You've got what you need for lubricity. You've got the components in there for tool life. You've got the components in there for biological control. You've got components in there to compensate for whatever kind of water you might be using. Those, as you get to the synthetics or the soluble oils, managing all that in one fluid becomes more challenging.
And do you have any input? We have hard water here. We're doing a softener and an RO system, but for folks that just aren't able to spend the time checking their water or figuring that out, any advice on whether they should just do that, or that there's coolants that are more tolerant of hard water or varying water?
Well, I've been saying for almost 30 years, manufacturing is about controlling variables. The number of shops that completely disregard water as one of the variables that should be looked at or at least considered is enormous.
People don't pay attention
ignore it. They don't pay attention to it unless it's so bad that the downsides are obvious. Like in Arizona and Utah, Southern California, Florida, the water out of the tap usually is bad enough that 80% of the shops are going to be treating the water.
Just have to be.
They have to, otherwise their sump life, instead of being a year, is 3 months. Residues in machines are dramatic. It's harder to keep parts clean. You use more product, not just because sump life is shorter, but you're carrying more out on the chips and on the parts. As a rule of thumb, you should always know what your water quality is. Whether or not you take action and whether or not it's bad enough to warrant putting in a system is another story. A lot of, let's say, soft water to medium hard water doesn't really require anything special if you're selecting the right cutting fluid. The more you get into harder waters, like Canada, for example, a lot of the products that we send to Canada are more hard water stable than we might send to other markets.
Interesting.
Because it's not hard enough that a lot of the shops treat it, but it's hard enough that a long-term impact can be felt by the customer.
John Grimsmo and I were just talking about this on the Business of Machining podcast, because he's moving into a new shop. He's got enough spindles now where we were saying maybe you should just go with the kind of full-blown DI system, which has a lot of benefits. But the thing I would emphasize as a bootstrapper is there's a TDS meter that's like $12. So we'll put a link in the description to the water quality video, but it's not expensive to test this, and obviously buying the meter will let you test it on an ongoing basis. My understanding is any distributor or water or coolant company will test your water.
Yeah, and if you're dealing with a reputable coolant supplier, they'll be happy to test your water and tell you what the story is. Because they don't want problems any more than you want problems.
Right.
They don't want 6 months from now to pick up the phone and you're yelling at them about corrosion because they didn't do what they should have done to take care of things. But yeah, we make it as part of the service we do for our customers. before we fill the system up, typically we like to know what the water's like. Now, we can generalize it for a sales guy that only calls on Ohio. He probably has a good understanding of what the water qualities are like all around Ohio.
Right.
And can sometimes shortcut the process by assuming
It's
the
funny
type
how
of
you
water.
can like build coolants for sort of state-specific
And country
regions.
specific, yeah.
Right. But again, if you're using a well, it's going to be totally different than a water that's been processed by a municipality. And we got burned on a synthetic because we didn't realize just how imperative it was that that synthetic not only receive perfect water at the time of filling up the sump, but on an ongoing basis. And so we had issues of, we goofed on our water system, and then the synthetic also was reacting with zinc or copper in the machine or in the parts, and it kind of was the eye-opener that led to me wanting to get smarter on this, just to make good decisions for what we're doing, but then share that with folks on.
Yeah.
Kind of made me think, wait, semi-synthetics just seems like a lot easier way to go.
I mean, the whole way the industry evolved, straight cutting oils
Yep.
became soluble oils. Soluble oils had rancidity problems, so the industry reacted and created synthetics.
Okay.
Synthetics were supposed to never go rancid, but they had other downsides to them. Eventually, semi-synthetics were supposed to be the happy marriage between the two different types of technologies. But again, if you have a well-designed synthetic
Yeah.
and it's supported properly by the factory and used correctly by the user, you can be as happy with that as any of the other technologies.
And I will readily admit, as frustrated as I was with synthetics, we were using it on our VM3, main machine that we make our fixture plates. And once we got that sort of nailed down, we absolutely saw an increase in tool life.
Yeah, it's surprising to a lot of people, but a full synthetic can actually deliver a lot more lubricity, not in the same way an oil-containing product can. But we have some synthetics that will blow you away on Inconel and titanium and aluminum. If you do all the things you need to use it properly, you're a happy user.
Well, folks, I want to say thank you again to John for coming in, sharing some education with us. Post your questions and comments below. I suspect they'll be more than willing to do this again, or if anything, just chime in with some actual real scientific responses to some of these things, because I feel like there's some old wives' tales in the coolant world or water world around the machine tool industry.
Yeah, wives' tales and snake oil salesmen are unfortunately what the coolant industry is known for.
Yeah, awesome. John, thank you very much.
Thank you, John,
I
for
appreciate
having me.
it.
Yep.
Hope you folks learned something. Hope you enjoyed. Take care. See you soon.